Hi everyone. Okay, so today we're going to do our second revision video for your revision test from third year. So we're going to start off by talking about measurements and how we measure things and what we're measuring. So let's have a look at what you're expected to do. So students have to have an understanding how to measure time, temperature, length, area, volume and mass. And also we're going to talk about density today as well. So you have to be able to think of suitable instruments to measure time, temperature, area, length, volume, mass, and be able to work out density as well. Some of the key words in this chapter or in this section are calipers, opposometer, trundle wheel, area, volume, graduated cylinder, meniscus, overflow can, mass, and thermometer. Now, calipers are something used to measure the diameter of a pipe. An opposometer is used to measure the length of a curved line, usually used when you're measuring, for example, rivers or roads on a map. A trundle wheel is used to measure a large distance. So, for example, marking out a football pitch, you'd use a trundle wheel. Area, we'll talk about that now in a second, and volume, we'll talk about that too. Graduated cylinder is a piece of equipment used to measure the amount of a liquid. It's quite an accurate piece of equipment. The meniscus is the curve that's seen on the top of water. So when you're measuring from in a graduated cylinder, you have to always make sure that you measure at the bottom of the meniscus. We'll talk about that again in a second. An overflow can is a piece of equipment that we use to measure volume of an irregular shaped object. We'll look at that again in a second as well. And a mass is how much matter something is made of. So for example, if you want to measure your mass, you step on a weighing scales and you get your kilograms. A thermometer is obviously used for measuring temperature. So let's have a little look further on. So first of all, measuring the volume of a liquid, something that we do repeatedly in science. So when we're measuring volume in the lab, you'd always go for one of these guys, which is a graduated cylinder. So for example, if you're measuring the volume of an acid or water or alcohol, for example, okay, you would pour your liquid in here, and it's really important that you get down at eye level with the liquid and you take your reading from the bottom of the meniscus. This is this curved line that forms at the surface or the top of the liquid. So you always take your reading from the bottom of that meniscus there. Now, when we're measuring volumes of liquids, the units we usually use are the following: either centimeters cubed or milliliters. Okay, so you can measure in either of those units. And let's skip on down here a little bit. Now, when we're measuring the volume of a regular shaped object, for example, like a cube. So a cube, for example, like this, is quite easy to measure its volume. You do this in maths. It's not a very well drawn cube, but you know what I mean. So if this was 2 meters by 2 meters by 2 meters, to measure the volume, you multiply 2 by 2 by 2, and that is 6 meters cubed. Okay, that's to measure the volume of a regular shaped object. You're only expected to know a cube for science junior cert, okay? An irregular shaped object, like for example a human or a funny shaped rock, you're going to have to do that slightly differently. So we have to use what's called an overflow can here, which is essentially a funny looking little teapot. It's a little can with a spout. So what you do is you fill the overflow can up with water right to this spout here, and then you place a graduated cylinder underneath the spout, and then you put your regular shaped object into the overflow can, making sure that it's below the surface of water. Whatever water flows out, you measure the volume in the graduated cylinder as discussed above, underneath the meniscus, and you get the volume there. Okay, so that's how you measure the volume of an irregular shaped object. When we're measuring mass, like I said, mass is the amount of matter something is made of, the amount of stuff or atoms something's made of. We measure mass in grams, kilograms, or sometimes we measure in old money or stones. You might hear your mum or dad talk about losing a stone. So they're kind of non-metric units. So grams, kilograms, or stone is usually what we use. Usually grams or kilograms is what you'd be using in science. Okay, so we use a mass and we use scales to measure mass. Okay, that's quite easy. To measure temperature, we always use a thermometer, or sometimes you see a thermometer probe either. So just like the one that takes your temperature when you're sick. Okay, so that's how we measure temperature. Now temperature is always measured in degrees Celsius or degrees Fahrenheit. Okay, now area is something we haven't spoken about recently. Area is the amount of space that is found within the lines of a 2D object. Now, so here you can see the amount of space within this area here. So for area, it's usually quite easy to measure the area of something. Usually it's a square or rectangle in science. So it's just a little bit like volume, where if it's 2 meters by 2 meters, you just multiply the length by the breadth together, where it's a rectangle or square, and you'll get 4 meters squared. So our units for area is centimeters squared or meters squared. For volume, remember that's how much space something takes up. It's cubed, centimeters cubed or meters cubed. So just be very careful with your units there, okay? So that's how we take the area of something. Now, when we're talking about density, which we haven't spoken about yet, okay? Density is how tightly packed atoms are in an object, okay? The other way it's described as well is that it is the mass per unit area of something. So let's have a little look at how to do density. So for density, the mass and its units are grams per centimeter cubed. Okay, we use a special triangle to try and work this out. Okay, now there's 2 triangles you need to know for science. One is Dad-Silly triangle, and this one is the following. MDV. M is for mass, D is for density, and V is for volume. Okay, so once you have your mass, which you get from a scales, and once you have your volume, which you get from an overflow can or by calculation, you're able to work out the density of an object. The way I get my class to remember this is my dog vomited. Really easy little sentence that will help you remember what goes on the top, what goes on the bottom. So let's have a little look how you use this triangle, okay? So remember, you take your finger and you cover over the bit that you want. So if we want density, we take our finger, we cover over that. And that is equal to mass over volume. If they're over each other, it's divide by, okay? If we were looking for volume, it would be we cover over volume, and it's mass over density, so that means divide by again. And if we were looking for mass, we cover over mass with our finger, and it is density multiplied by volume, because they're beside each other in the triangle. So that's how we use our triangle here, okay? Now density becomes important when we're talking about flotation. So here we can see the apple is less dense than the potato because it is floating. And this is more dense. Now, the reason the apple is floating is because its density is less than 1 gram per centimeter cubed, because that is the density of water. So we know that it's floating, so therefore its density must be less than that of water. So less than is this sign here. We know that the density of the potato is the opposite. It's greater than 1 gram per centimeter cubed because it is sinking. Okay, so we always know if something sinks, its density is greater than water. If something floats, its density is less than water. So this is an important value to remember as well. Okay, so that's everything you need to know for the next test. Best of luck with that.